This is very important. Acid-fast stain is the #1 method, a very preliminary method in the clinical area to differentiate whether some people, if they have a conductive coughing, have a fever, have a cloudy area of the lung area, is because it's tuberculosis. Once you have acid-fast positive results, this guy, usually we say it's clinically presumptive TB positive. You have to use antibiotics immediately. The reason is, if you really culture, let's say we're growing a microbacterial tuberculosis, it took you about a week or two to do it. So acid-fast stain is a very basic method to testing microbacterial tuberculosis in the clinical area. Now, lots of the time, especially modern days, people want it to be a TB. Is that right? Because we have antibiotics. You don't want really to end up with a cancer. That's not good. So when you have a cloudy area of the lung area, if you tested TB, 100 years ago, you will be very sad because that means you're almost dead. But right now, you will be happy because we have antibiotics. You don't really want to end up with lung cancer. Okay, one way or the other, you like TB right now. But I tell you, 100 years ago, nobody can do it because no antibiotics. No, there's only a problem right now is that because we are using those antibiotics too much, so microbacterial tuberculosis become multiple drug and multiple antimicrobial or antibiotic resistant. That's a major risk issue right now. They happen. Okay? Let's talk about several things next. Indospore stain. The next one is indospore stain. Indospore stain and acid-fast stain, there are some steps are very similar, just a different dye. So we want to mention this indospore stain. We talk about there is a two bacteria has indospore, basically Clostridium and Bacillus, because they are originally coming from the soil. So we want to test the indospore. Now, why we want to see the indospore? Why we want to do the indospore stain? Number one is presence, absence of indospore. So said very simple, is there indospore? That's a question. Number two, we want to see the location of the indospore. Because there is a different location for the indospore. That could be in the center, could be at the end, we call it a terminal. And there also could be right in the middle, we call it a subterminal. Okay, why it is important for the location? Because the location is genetic dependent. Let's say Bacillus most of the time is subterminal, and some of the Clostridium is terminal. So we can see the difference between that. Okay, how to do indospore stain? Indospore is a very rigid structure. We'll talk about next week. The basic dye will not go inside. So what are we going to do? Let's say you have a glass lens. Okay, you make a smear. Let's say this is the Bacillus subtilis. Okay, what we have to do? Very rigid structure. You have to flood in with a green dye called malachite green. This dye have another function. Some of the bacteria will be killed by malachite green. Okay, so you're going to have to flood in with malachite green. Then what you do? Again, the fire will be from the Bunsen burner will be go on the top. Has to do heat, steaming for 5 minutes. Or you use a water bath. The same thing, coming from the bottom. After that, you have to do rinse, and then you counter stain with safranin. So, what going to be the final looks like? Look at the picture right here. The second picture is the endospore, what it looks like. A little bit of greenish color, a big purple, a greenish color, bubble right in there. That's the endospore. Now, here is something I want to mention. Remember, the gram stem, we said you have to use a young culture. Is that right? Only 24-hour fresh. For endospore stem, you have to use an older culture. And usually this has to be at least more than 72 hours. Why? Because endospore is a protection structure. In the very stress environment, bacteria will have endospore. Even if for Bacillus and the Clostridium. That's why you need to let them grow a little bit older. If it's very young, it will not have endospore. Now, there's one exception for Bacillus cereus. Bacillus cereus is grow really fast. 24 hours will have endospore. But that's one or two exceptions. Most of the bacteria need time to do the endospore, taking several days to do. Okay, that's endospore. Next one is capsule stem. So we want to talk about capsule stem. We'll end up with, we finish talking about capsule stem, okay, the last one. Capsule stem, there is two methods we can do. Number one is negative stem. Okay, why we can do negative stem? What is capsule? We mentioned about this. Okay, let's say Streptococcus pneumoniae. We have a two coccale inside, which is called the diprococcale. This area is capsule. Very heavy polysaccharides. The protection function to anti-phagosome. Macrophage cannot engulf it, cannot eat it because of the capsule. So we don't want to really stain these bacteria, we want to stain the capsule. But how are we going to do? Let's do that. Let's stain the background. Is that okay? It's very magical. I'm going to stain right here. Then it showed up. Now how to do it? You have one glass slide like this. You put a bacteria there. Another slide is on the top. Repel. Like you do the red blood cell in the other classes. Repel it. Makes the very thin layer, then you dry. Now, what is the dye? Nigrosin and Indian ink. Those are the two dyes we're using. It's acidic dye. Is that right? It is negative charge, so they charge the background. That's a negative stain for the capsule. The picture right here on the top is the negative stain. The capsule showed up, the background is stained. Look at the color, look at the black area, or greenish black area. Greenish white area, sorry, that is a capsule. There is a second method what you could do is directly stain. If you do a directly stain, you need using, that is somehow around like 30% copper sulfide. Not many people to do this because it's difficult to do. This is the method what we can do for the capsule stain. Okay, last one, flagella stain. Let's finish this right here. Okay. We'll talk about flagella a little bit of detail, but here we talk about flagella stain. First of all, you need to know, flagella is very special structure for bacteria, which means true mobility. Bacteria can move, is that right? Sometimes they do the tumbling. Does not really move. If they really move on from location A to B, they need the flagella. So most of the flagella is like this, like a tail. Okay, now how are we going to stain that? There is some methods we could do. There is one of the methods is very similar to this, using copper sulfide. to stain it. Same thing. Okay? But we don't like that. That one is not really good. Most of the time when we're using the methods, you need 2 slides. These slides, let them put 1 drop of flagella. Because flagella is very thin, very soft. They're composed by a protein called flagellin. So very soft. So when they roll in here, they're going to become like this. Now I have to make sure it is stacked there. So what we do? We add tiny gases. We add tiny gases to stick it. Then finally I got to put another layer. Okay? It is called platinum. You need to put and silver, metal, palladium to seal it. And finally we'll see the flagella. That's what the flagella stain looks like that. I believe this one pretty much is using the copper sulfate just to the director one. Looks like it a little bit of color in the middle, and that's a flagella showing. Unfortunately, we won't do any of these in the lab. In those spore stain, we will do it. Acid fast stain, I used to have a microbacterial culture, but 3 years later it's dead, so nobody's recovered it, so we don't do it at all. But basically, it's the same as in those spore stain. Okay, so we'll finish around here.